Hello everyone. So let us discuss the second module of water resource management, that is water resource planning and management. So in the second module, the first concept is what is the need for planning and management. So as we are discussing here, it is all about how to maintain the quality and quantity of water. So the first thing is whatever is available should be maintained thoroughly. So that is the need for, there is an important concept, that is the need for understanding why we have to conserve and save water. So the first thing is need for planning and management of water system. So the main resource of water is water basins or the river basins. So if there is too much of water, it undergoes floods, and if there is less water, it undergoes droughts. And if the water is available and which is not cannot be used, becomes polluted water. So if there is too little water, then there is a problem, because due to urbanization due to the development in the city buildings, so there is water requirement is less. So because it will be used for urbanization, and if there is too much of water, it increases the flood frequencies. And if there is a polluted water, and because of industrial and household discharges, it cannot be used. So all these three parameters should be studied properly. And so if there is too little of water, so there will be conflicts between the private property as well as the public rights, because equal water should be allocated for both the parameters. And this may lead, at times it may lead to groundwater abstractions, and so supplement water is required. So the storage volumes and the surface water should be thoroughly used and balanced. That is about water usage. And if there is too less water, so there should be a balance in the water system. And the next thing is, if there is too much of water, it may lead to the, especially in the developed regions, it may sometimes, the level of the annual flood damage is more. And because of this, to restore things like before, the expenditures due to flood damage will increase. And recently we have observed that in the past couple of months there was floods everywhere, and that's how we have to restore the water. If there is too much of water, it should be planned properly, and that's how dams are constructed across, and the reservoir capacity is increased. And the third quantity is the polluted water. And especially in the polluted water, the aquatic life is, there is actually a threat for aquatic lives. And there's a lot of conflicts between the upstream side and the downstream side, because both the upstream side and downstream side should meet the water quality standards. And pollution discharges from the sediments or from the industries should be properly treated, otherwise it causes sediments, and that's how it reduces the reservoir capacity. Next, inadequate, if there is inadequate water protection, that is especially the groundwater, if the groundwater is not protected properly, then again this will cause a nuisance. So all the three parameters should be studied thoroughly, because if there is too much of water, there is a problem. If there's too little water, is also a problem. And if there is a polluted water, that also causes a problem. So these three parameters, in these three parameters, ultimately water should be stored. So quality and quantity of water plays a vital role. Next, the degradation of aquatic and riparian system. So if the aquatic, that means aquatic life should also be maintained, because it again somehow is dependent on the food chain and the riparian system. So riparian system is nothing but the offshore or on the bank of the river. On the bank of the river, there is aquatic life, or there would be a uh, forest, or any type of any type of trees, which will obviously reflect the, and somehow it again affects the aquatic life. And so this two things also should be, that means the aquatic life in the water and the riparian system, it is on the banks of the river, both should be maintained from degradation. And next thing is port development. Now port development um, is nothing but for transportation, or to store, or transportation of seas. Port means basically it's a seashore. So seashore project should also be developed. So that's how there is a need for protecting sea water also. And next thing is riverbank erosion. So there is a riverbank erosion and the degradation of riverbed. And now this happens because of erosion and degradation, because of if there is excessive water which flows through the river. So along with its flow, there's a too much of gush of water. So with its flow, it erodes the soil beneath that, and that soil gets carried over to the downstream side also. And when it carries the soil with it, so it mixes with the water. Soil basically it's form of a clay, very small silt will be carried, and that's how from the upstream it is sent to the downstream side. And in the downstream side, it reduces the reservoir capacity. So upstream side and downstream side, the water quality as well as quantity should be measured. And finally, because of this erosion, there is a sediment accumulation in the reservoir. So if the sediment gets accumulated in the reservoir due to poor water quality, now again, poor water quality is nothing but water, if it mixes with other debris, or other material or other sediments, so when it mixes with this, it will cause a sediment accumulation. Now sediment accumulation gets accumulated at the bottom of the reservoir, and thus, because over a period of time it goes on accumulating in the reservoir, and then it reduces the capacity of the reservoir. Say for example, if the reservoir capacity is 100%, so over a period of time this water will settle water with silt, it will settle at the bottom, and it reduces the capacity. And if it reduces the capacity, obviously the water capacity is reduced, and then this sediment water capacity is reduced, and this sediment causes degradation of water. Okay, so the next thing is, there are three system components. That means these are the three components which are introduced into control the water resource management. So they are natural river subsystem, socio-economic subsystem, and the third one is administrative and institutional subsystem. So all the subsystems are interdependent. So you can see that first, natural river subsystem. So it's itself in the name. So natural is nothing but it is through the nature. So through the nature, it could be physical, chemical process, or biological process. So that means this all are available in the nature. It's all dependent on the nature. So this nature, which is used by humans, that is due to socio-economic subsystem. So this mm, natural river subsystem is used by the human activities, and these both are interlinked. I'll just tell you in the next diagram. And then these two subsystems are governed by administrative and institutional subsystem. So this administrative subsystem, it forms some rules and regulations for decision planning and management of the process. Now you can see that in the diagram. So the diagram is self-explanatory. Now you can see here in this diagram there are three quantities, there are three bodies. One is this is administrative or institutional subsystem, third quantity, natural river subsystem, and then this is socio-economic subsystem. Now you can see here this is natural river subsystem, so it is natural boundary condition. So natural boundary condition is nothing but what is appearing in the nature. So what appearance in the nature is like the forests or the rivers, river basins, watersheds. So that is all naturally available. This naturally available subsystem is, again you can see here, it is used by socio-economic subsystem. So socio-economic subsystem is nothing but the human beings. So this is naturally available and this is used by human beings. So this human beings and natural systems are interdependent. So whatever happens here, it impacts the resources. So natural river subsystem is dependent on socio-economic subsystem. So human beings play a very important role because they in turn affect the river system. So if rivers are protected, it's all because of socio-economic subsystems. So these days there are measures to control and clean the rivers. So that's how these are interdependent. You can see the arrows here, and then both are governed by the administrative and institutional subsystem. Now this is the center and the state government makes some rules and regulations through infrastructure. It builds the infrastructure and makes artificial rivers at times, and the same government, the state and the central government, makes some rules and regulations for the human beings, that is socioeconomic, then basically human beings, human activities, human beings, any human related activities. So it makes some regulations for the human beings, and both are controlled by the system. So this is like natural river subsystem building or making rivers available for human activities using some rules and regulations in order to maintain the impact and balance the human activities. So again, human activities could be navigation and fishing. It could be a transportation, anything as such through the seas or the rivers. So all these are governed by this parameter. So both are intellect. This can damage human beings or human activities can damage river subsystems. So that's how it is governed by the administration, that is the government. So it builds infrastructure to maintain the rivers, it forms regulations for the human activities, and if both all three are interdependent, if any one subsystem, if any one subsystem is undergoes loss, then it affects the complete system. So that's how it is all a cyclic process. It's a cyclic process, and so we have this as okay. So any inadequate attention to any one of this system can destroy the any form of work done to improvise the complete system or the performance of all the three. Okay, so the next thing is okay. Now there are some planning scales. So we understood there are some planning scales to improve the system. That means the above system, all the three above systems. To improvise this, there is some planning done. So there are two types of planning in this. One is spatial scales for planning and management, and the next thing is temporal scales for planning and management. Okay, so first thing is the spatial scales. Now, spatial scales is nothing but, it's again in the word itself, spatial. That means space. Now, space is nothing but, we have two things here. We have to manage the land as well as water. Space. So, land and water. So, it mainly governs how land and water are going to be managed. So, this system deals with managing the land as well as water. Now we know that there is a watershed or this river basins usually considered for logical reason. So logical reason as in, basically these are the two important, like these are the important uh, resource for water. So these are the watersheds and the river basins. Watersheds or the river basins are a matter of interest. Now they should be properly maintained and planned, and then the water should be withdrawn properly and managed. So again, in this, how land and water are managed in one part of the river basin can affect the land and water in other parts. That means, for example, if the discharge, now the meaning of this is the discharge, for if you consider the example for this, the discharge of pollutants or clearing of waters in the upstream portion of the basin may degrade the quality and discharge and increase the flow and sedimentation in the downstream. It means now here, if in the upstream side of the land and water, if I discharge the pollutants through the industries, the same pollutants would be again carried to the downstream side, and that's how it, because it is carried and in the downstream side it settles, so it affects the downstream parts. So this has to be properly managed here. Next, the construction of dam or weir. The construction of a dam or a weir in the downstream side of the river may prevent vessels and fishes from traveling upstream. So if you constructed a small dam or a weir in the downstream side, so obviously there are chances that it doesn't travel. So the it may prevent the vessels. Now vessels are nothing but small ships. It may prevent the vessels or the ships from traveling upstream side, and that's how the pollution can be controlled. So the main disadvantage of this is, so maybe it is inadequate for addressing particular water resources problem and caused by events taking place outside the basin. So these are, it is restricted to maintaining the water only in the river basins. So it doesn't take care of water outside this. Like maybe it is in the through trees, water storage through streams or surface waters. So hence there to understand this, there we should have a problem shed area. There's a problem shed area to study this concept in a wider sense. So that is the spatial system. So basically spatial system, spatial scales, it only deals with the river basins. It deals with the river basins or the river sheds or the small catchment area, small pond rivers, which should be maintained and planned properly in order to extract the water and maintain the quality on the upstream side as well as downstream side. Next, okay, so the second concept here is temporal scale for planning and management. So temporal scale is nothing but, it is again in the name itself. Temporal means it is based on the time. So temporal means it is time based. Now, if you have noticed throughout the year, we have because again weather in our country is very seasonal. So there is rainy, winter, summers, and throughout the year we have a different type of water activities as well as water management. So again, it is a time based. So in this case here, the first thing is in temporal, because it is time based, so we should plan properly. That is, decision should be recommended for immediate future or a long term. So for example, if you can notice here, there is a irrigation planning and summer season water recreation. Okay, now see here, during rainy season we need water for irrigation, and that water should be properly stored in the reservoir, and then it should be shed through the adjoining rivers for agriculture, adjoining places also. But in summer what happens, because there are, the water requirement, the water quantity is less, water quantity is less, but requirement is more. Okay, water quantity is, so here there is more water, and this water can be used for agriculture. Here there is less water, but because it is summer, we need it for other activities as such. So because that's how it's called as a time based. So because it is a time based, wherever there is a plenty of water, which should be stored in reservoir, and that's how dams are created. And whenever there is excess water which is stored in dam, and whenever there is a drought, especially in summers, that water, stored water, is released for summers. It's released for summers, as in in summer season it should be used for other purposes. So that's how it's called as a time based. So a time based is nothing but the water resources plans needs to be periodically updated and adapted. It should be periodically updated as well as adapted, and new objectives and new forecast for the future demands, as well as the cost and the benefit should be studied. So in this case, planning is a continuing sequential process. So because it is time based, so every now and then there should be a planning depending on the requirement and the demand. So it is very important how far into the future one needs to look, because it's, we have to try to look into the present and also try to plan for the, you have to forecast for the future. So assessing the impacts of water quality and quantity management, so both is important here. When you're maintaining the quantity, at the same time quality also should be managed, and that's how one has to check both the processes, that is temporal and spatial scales in the system planning. Okay, thank you.